In this session, we'll take a look at quadratic equations and the methods that are used to solve quadratic equations. So here is the basic form of a quadratic equation. A quadratic equation in standard form is listed as ax squared plus bx plus c is equal to 0, right? And this is the standard form of a quadratic equation. Now, how do we solve quadratic equations? Well, we solve quadratic equations in a couple of ways. The two ways we're going to take a look at solving quadratic equations here are, we're going to solve by factoring. So these are methods to solve methods to solve quadratic equations. We're going to use factoring and the quadratic formula. Okay, and these are the two best methods that are used to solve. The quadratic formula, however, can be used to solve any quadratic equation, whether it's factorable or not. The factorable method depends on if it's factorable or not. However, the quadratic formula can be used to solve any quadratic equation. All right, so let's take a look at an example. So in this example, we're asked to solve x squared plus 5x plus 6 is equal to 0. Right? Whenever you solve a quadratic equation, the first thing you want to do is you want to make sure that your equation is in standard form. So what does standard form means? Well, standard form simply means that your equation must be set equal to 0. If your equation is not already set equal to 0, then you must force it to set equal 0, and then we're going to proceed to factor. We're going to factor using something called the product sum method. And here's how the product sum method works. We need to find two numbers such that the product is going to equal to 6. So notice I have the product and I have C in parentheses. Well, if we go back to the standard form of a quadratic equation, C is actually that constant on the end. So we need two numbers that are going to give us a 6. We're also going to use the sum. So notice for the sum, I have the coefficient b. That's supposed to be a b. And notice that b would be the coefficient of our first degree term. All right, so we need two numbers such that when we multiply, we get 6, and when we add, we get 5. So we're going to look at all of the factors of 6. So the way we can get 6 is by using 1 times 6, because 1 times 6 is 6. We could also use 2 times 3, right, because 2 times 3 is 6. And we've exhausted all of the whole numbers we can use to get 6. So what two numbers are we going to use? Well, the two numbers we're going to use are 2 and 3, right? Because 2 times 3 gives us 6. 2 plus 3 gives us 5. Right, so our two magic numbers are 2 and 3. So I'm going to place x in the front of both of my sets of parentheses, because when I multiply my first terms, I should get the first term in my trinomial. Whatever I put for my last terms, I should be able to multiply to get the last term in our trinomial. However, the trick here is the middle term. The middle term has to satisfy a product of 6 and a sum of 5. We've already determined that it's 2 times 3. So our correct factorization would be, I'm going to write an extra step here, x plus 2 times the quantity x plus 3 is equal to 0. Next, we're going to use something called the zero factor property. And the zero factor property says that, and I'll write it here on the side, if you have two factors whose product is 0, right, if A times B equals 0, then you can set each factor equal to 0. All right, so in our problem, x plus 2 times x plus 3 is equal to 0. We have A is going to serve as x plus 2, B is going to serve as x plus 3, and it's set equal to 0. So we're going to use the zero factor property, and I'm going to write this as x plus 2 equals to 0, and x plus 3 equal to 0. So now we have linear equations. So in order to solve x plus 2 is equal to 0, we'll simply subtract 2 from both sides. And to solve x plus 3 equal to 0, we'll simply subtract 3 from both sides. And we have our solution, -2 and -3. So notice there are two solutions. Now, we can still check, just as we check our linear equations. So remember, in order to check, we will go back to our original problem, right, which is x squared plus 5x plus 6 is equal to 0. And when we check our numbers, we only want to check one number at a time. So first I'll check -2. So wherever I see an x, I'll place in a -2. So here we have 4, 5 times -2 is -10, right, plus 6 equal to 0. So we have 0 equals to 0, so we know our solution of -2 checks out. We can also check our next solution, -3. So we have x squared plus 5x plus 6 equal to 0. Here we're going to check -3. So wherever we see an x, we're going to replace with -3. And we can see that both sides are equal to 0, so we know that -3 is a valid solution. All right, so now let's take a look at another example. Okay, so here we're asked to solve x squared plus 2x is equal to 24. All right, so in order to solve this quadratic equation, we know it's quadratic because our highest power is a square. Next, we're going to put it in standard form. So I'm going to force it to equal 0 by subtracting 24 from both sides. So we have x squared plus 2x minus 24 is equal to 0. Right, so the first step is to make sure it's in standard form if it's not in standard form. The next step, we're going to make two sets of parentheses. Now this problem is unlike the previous problem in that our last term is negative. So I'm going to go over here to the side, and we're going to write out how to determine your signs. So I'm going to write out the 4 different scenarios. Okay, so this is what we're going to use to determine signs. And it may look a little bit confusing, but I'm going to explain it to you. And it's based off of the sign of the last term. So if we look at the first 2 setups, notice that in the first setup, my last term is positive. If the last term is positive, then your signs are going to be the same sign as your middle term. So notice in the first setup, my last term is positive. My middle term is positive. So both of my numbers that I'm going to use in my factorization should be positive numbers, right? If the last number is positive, both of your numbers will have the same sign as a middle term. So let's look at the second setup. In the second setup, my last term is positive. So that means both of the numbers that I'm going to use in my factorization should both be negative numbers. So notice that in my setup for parentheses, both of the numbers are negative. If you look at the third and fourth setups, they both say that if your last term is negative, it does not matter what the sign of your middle term is, one of your numbers has to be negative and one of your numbers has to be positive. Okay. So in a nutshell, if your last term is positive, then you're going to have 2 signs the same as your middle term. But if the last term is negative, it doesn't matter what the sign of your middle term is, one of your numbers is positive and one of your numbers is negative. So how would that help in solving quadratic equations? Well, look at the following setup. We have x squared plus 2x minus 24. So I'm automatically going to place an x in the front of both sets of my parentheses. Since my last term is negative, that means one of my numbers has to be positive and the other number has to be negative. We need 2 numbers whose product is equal to negative 24 and whose sum is equal to positive 2. Keep in mind that one of the numbers is negative and one of the numbers is positive. So now in order to determine the numbers I need, I will concentrate on the last number, which is 24, right? I'm going to find all the factors of 24. And I want to find out if there are 2 factors such that when one is positive, one is negative, you get a sum of 2. Right? So we're going to go through. So 24 can be 1 times 24. We can have 2 times 12. We can have 3 times 8. we can have 4 times 6. And I believe these are all of the factors of 24. So now I'm going to take into account that one of the numbers has to be positive and one of the numbers has to be negative, so that when I add them, I get a sum of positive 2. So I'm going to use this last combination of 4 and 6, right? But what kind of 4 should I use and what kind of 6 should I use? Well, I know that my sum is positive, so the largest number should have the positive sign. So the two numbers I'm going to use here are 6 and -4, right? 6 times -4 is -24, but 6 plus a -4 is a positive 2, right? So our two magic numbers are positive 6 and -4, right? So we have x plus 6 times x minus 4 is equal to 0. I'm now going to use the zero factor property, so I'm going to take both factors set equal to 0. And if we solve, we have x is equal to -6 and x is equal to positive 4. All right, so now we'll take a look at a third example. So we're still solving quadratic equations. So here we're asked to solve x squared plus 5x plus 2 is equal to 0. Okay, now when we solve quadratic equations, the first thing we should look to do is to factor and solve. All right, but not all problems are factorable, right? So based on that product sum method we use, is it possible to find two numbers whose product is 2 and whose sum is 5? Right? That would be impossible to factor. But since it's not factorable, that doesn't mean we can't solve it. We just have to find a different method to solve. So the next method we're going to use is called the quadratic formula. And here is the quadratic formula. It says that x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So we're simply going to put our equation in standard form, all right, and it's already in standard form. And we're simply going to pull out a, b, and c. A would be the coefficients from our squared term, which is 1. B is the coefficient of our middle term, which is 5. And C is the coefficient of our last term, which is 2. Right? So we're going to substitute these items into the quadratic formula, simplify for the solution. All right, so here we have x is equal to -5 plus or minus the square root of b squared. So that's 5 squared minus 4 times a times c all over 2a. So we have x is equal to -5 plus or minus. So with inside of the square root, we have to follow the order operations, right? Please excuse my dear Aunt Sally. So we want to do what's in the innermost parentheses first, right? And there is no innermost parenthesis. Next, we'll evaluate our exponent. So 5 squared is 25. Now we'll multiply -4 times 1 times 2 to get -8. right? We're going to divide that by 2. So now if we simplify our square root, we have -5 plus or minus the square root of 17 over 2. Now the plus or minus separates our answers out into 2's basically. So we're going to write this out as x is equal to -5 plus the square root of 17 over 2. Okay, and that's one solution. And the other solution is -5 minus the square root of 17 over 2. And lastly, we're going to talk about something called the discriminant. And the discriminant it tells us how many solutions that a quadratic equation could have. Okay. And a discriminant is actually the b squared minus 4ac portion of the quadratic formula. So I kind of go up here, notice that the square root contains a b squared minus 4ac. b squared minus 4ac is the discriminant, right? So here's what the discriminant says. It says that if b squared minus 4ac is equal to 0, then you have a one solution for your quadratic. If the discriminant b squared minus 4ac is positive, so greater than 0 simply means positive, that means you will have two solutions when you solve your quadratic equation. And the third setup, if b squared minus 4ac is negative, so anytime you see less than 0, that simply means negative, then you have no real solutions. All right, so let's look at an example. So here we're given x squared plus 3x minus 10. We're asked to find the discriminant and the number of solutions. All right. So we're simply going to take the discriminant, which is b squared minus 4ac. Right. I'm going to pull out a as 1, b is 3, and c is -10. Right, and we're going to simplify. So we have b squared, so b is 3, minus 4 times 1 times a -10. So 3 squared is 9, plus 40. Right, because a negative times a negative is a positive. 4 times 1 times 10 is 10. So we have a discriminant value of positive 49. Since our discriminant is positive, then it's going to have two real solutions. So the discriminant is 49, and the number of solutions is 2. Thanks for watching.